As a 20-year-old in college, I had testicular cancer. And so I went from a very cavalier, cocky 20-year-old to a really scared kid. And one thing that really impacted me is when I met with the oncologist, he told me, you really don't need to worry. We have about a 95% chance you'll be cured. And fortunately, it ended up being true. It was 14 years ago, and now I'm doing well. That really redirected what I did for my career, because at that point, I was a biomedical engineering major, and it really made me turn into tunnel-visioned medical oncologist. And in my training, I quickly learned that lung cancer is a very different kind of cancer. Not only is it the most common cancer killer in America, it's also the most common cancer killer in the world, and it's an extremely difficult cancer to treat. Almost unanimously, patients are succumbing to the illness, and I decided to really take on this kind of cancer because it was very different than what I experienced. So one thing that frustrated me about lung cancer is that after about 30 years of research, we've made very little progress. And so I decided that when I chose to study lung cancer, I would take an unconventional approach. And so that's what led me to studying nanoparticle technology. And so I decided to attack lung cancer in two ways. One is to attack what it is that kills lung cancer patients, and that is metastases. And so most research is more focused on how to slow down the growth of a tumor or induce death within the tumor. But ironically, that's not what kills patients. What kills patients is that the fact that the cancer spreads. And so my research is really focused on what is that biology that allows a tumor to spread, and in particular in the context of lung cancer. But there's another element to that that's also requires more unconventional thinking. And that is that most of the things that make cancer spread are not so-called druggable. So you can't use some of our current conventional technologies, such as small molecule inhibitors, monoclonal antibodies, or even chemotherapy to block these processes. And so I employ something called nanotechnology, where we use nanoparticles. And within these nanoparticles, we package tiny RNAs. And the RNAs actually have the ability to go into the tumor, penetrate the cancer cells, and actually shut down the genes that are allowing the cancer to spread. And so far, we've had very neat successes with shutting down the metastases of lung cancer. And it's certainly my hope that within the next several years, we can start translating this to the clinic.